Hi everyone and welcome to the internet. So what we're going to be doing in our lesson today is looking at stretching springs. So the whole idea is by the end of this lesson you're going to be able to explain how to stretch, bend or compress an object. You're going to be able to describe the difference between elastic and plastic deformation, and you'll be able to describe the relationship between force and extension for a spring. Now, to start us off and hopefully get our brains all up to speed and working, I've got a little formula quiz for you to have a go at first of all. So on the screen there you can see there are 5 starts to formulas that you've already met. What I want you to do is in your books finish off those formulas. So you've got 5 there, so I'm just going to give you a little bit over 2 minutes to get those done. Off you go. Okay then, let's see how we've actually done then. If you've got it right, give it a tick. If you got it wrong, it's a cross, but write the correct one next to it. So work done is force times distance. Power is work done divided by time. Force is mass times acceleration. Acceleration is the change in velocity divided by time. And speed is distance divided by time. So add them up and let me know in the chat box how you did. Who got 5 out of 5? Who got 4? Give me a number over in the chat window now. So first thing I want you to do then is in your books, just write an answer to this question. What happens when we apply a force to an object? So when we actually apply forces to an object, what we're actually going to see is that something is going to happen to it. Now, if we apply 2 or more forces to an object, we may see it being compressed, so squashed down, as you can see in the picture on the far left there. You may see it being stretched, as you can see in the middle picture, or it may get bent, as you can see in the one on the far right. So what I want you to do is, looking at those three pictures, and look at the arrows, because remember the arrows represent a force, is have a go at describing the forces that need to be applied to cause compression, to cause stretching, and to bend an object. So I'll give you a couple of minutes to write down your thoughts in your book. Off you go. Now, ordinarily, what we'd be doing is we'd be setting up an experiment where we've got a spring, like you can see in the diagram there, attached to our clamp stand, and then we'd hang different masses underneath it to see what happens to the extension of our spring. Now, I very much doubt that many of us currently have sitting around at home clamp stands and clamps and springs and masses. So what we've actually got is a little simulation I'm going to show you in a minute. But before we have a look at that, what I want you to do is have a little think, and if you were about to carry out this experiment, so you've got your clamp stand with the spring hanging on it, as we can see there, what will actually happen when we add a greater mass onto the spring? Write me a prediction in your books now for what's actually going to happen to the extension of the spring with increasing mass being hung on it. I'm just going to give you a couple of minutes to get that done. Okay, so I managed to find an online simulation that allows us to do a virtual experiment under Hooke's law. So what we need to do is go to the web address that I'm putting on the screen for you there. Now, once you go to this web address, what we're going to find is that there's a section called Intro. Okay, so this bit here, so you click that, and then it opens up this screen. So this is our experiment screen. Now, what we're actually going to do is you're going to be using a ruler and whatever device screen you're looking at to measure the length of our spring. So you're going to measure from this point here, the very edge of the spring, all the way along to the end of the spring here. So you need to start off by getting a measurement of that first of all and jot that down in your book. Okay, so that's with our force of 0, and then you can write down the extension is obviously going to be 0 at this point, but you need to know how long that spring is. Okay, so write down the length of the spring and the force. Once you've done that, then what we're going to do is we're going to increase our force to 10 newtons just by dragging the slider along, and then you can measure the length of the spring once more. Exactly the same thing, end to end, and write that down. Once you've done that, increase it to 20 newtons, same thing again, and keep going until you've got it all the way to 100 newtons. Now, what we actually have there then are a set of results. Now, before you all dash off to go and play on the simulation, then I'm going to give you a link at the end to some more instructions on how to use it and what to do with the information you get from it. So stay with us here for the rest of this video, and then I'll point you in the directions of how to use that at the end. If we look at what we've got on the screen at the moment, on the top left we can see that we've got a graph that shows the weight and the extension. Now on the x-axis we've got the weight, so x-axis is the horizontal one, remember, and on the y-axis, the vertical one, we've got the extension. Now all I've done here is just take a set of experiment results where we've carried out this experiment on Hooke's law and we've plotted those results out. Now what we can see is we've actually got two different sections of the graph, if you like, when we're trying to explain what's happening. So we're going to start off looking at the left hand side first of all. If we look at the left hand side of the graph, what you can hopefully see is that as the weight increases, the extension increases. But going a bit further than that, what we actually have is a linear relationship because we've got a straight line there. So what we know is that if we increase the weight by a fixed amount, so if we go up every 0.2 newtons for example, then the extension will also increase by a fixed amount. Hence why it's a linear relationship we've got there. Now this doesn't actually continue endlessly. What we can see is as we get towards the right hand side of the graph there, then you can see it starts to curve. Now the reason for that is that we've reached something called the limit of proportionality. So where that graph starts to actually curve and it loses that linear relationship, that is our limit of proportionality. And sometimes on an exam they'll ask you to put an X on the graph where the limit of proportionality is. So all you do is you find the end of the straight line and put your X on there. Now if we think about what's happening to our spring as we add greater masses onto there and therefore increase the force, then what's actually happening is it's going to extend in this nice linear way for a while, and when we take those masses off, it will be able to return to its original length. But if we add more masses than it can actually withstand, so we go beyond something called the elastic limit of our spring, then when we remove the masses, it doesn't go back to its original length. It stays stretched out. And every time we do this in school, there's always someone who doesn't listen to the instructions and adds way more masses on there than they should. And then we get this overstretched spring coming back that is now useless. So you won't be able to do that, but it does obviously explain what's happening to our springs. Because our springs have an elastic limit, then it will return to its original length beneath that. But if we go beyond the elastic limit, when we remove that force, it will not return. So what we say there is that the spring is permanently deformed. Now, what you've got on the screen there are 4 sentences with some words missing. What I want you to do is write those down in your books and have a go at filling in the blanks. So all the words you need are in the little red checkered box on the right hand side of our screen there. So I'm going to give you a few minutes just to have a go at getting those sentences finished off. And obviously, if you're not sure, you can always scroll back to what I just said, or you can always ask for a bit of guidance in the chat. So just give you a few minutes to get that done now. So still thinking about the graph we've just been looking at, if we double the force on our spring, then our extension is also going to double because it's this linear relationship. Now, what we could say is that the extension of a spring is proportional to the force until we reach the limit of proportionality. So obviously, that's a nice little statement that we can just remember there. So double the force on the spring, the extension doubles, and the extension of a spring is proportional to the force until we reach the limit of proportionality. And that, quite simply, is what Hooke's law states. So that is Hooke's law there. Now, we do also need to know a formula, which we can see in the bottom there. Force exerted by a spring in newtons is the spring constant in Newton meters times the extension in meters. So what we actually need to do there is learn that formula, folks. It's one they're not going to give you, so add it to your list of formulas to memorize. The other thing that we can do from our graph is actually calculate the spring constant. So that once you've plotted the graph, what we can actually do is on that linear section, so the straight line at the beginning, if we work out the gradient of that line, then we know the spring constant. And the spring constant quite simply tells us how stiff the spring is, so how easy it is to actually make it extend. The higher the number, the harder it is to do that, and we have to apply more force to actually extend our spring. Now, if we're looking at calculating our gradients, I'm going to give you some practice on this when it comes to the actual questions I'm going to give you towards the end. So what we actually have got here is Hooke's law first of all, our formula we need to know, and just that little reminder of how we can calculate the spring constant. So I'll just give you a couple of minutes just to get those points written down and obviously fill in those 3 blank spaces for me in your books. Just to finish off today then, have a go at least a couple of the questions that we've got on our screen here. So if your target grade is up to a grade 5, then have a go at the first 2, the grade 5, grade 6 columns. If your target grade is more than a 5, then have a go at the 6 and the 8s. It will just give you a chance to practice the work that we've gone through today. So I'll leave these on your screen for a couple of minutes and then I'll explain where you can find the extra resources. So have a go in your books at answering a couple of those questions. If you need help, then ask in the chat window. So as I mentioned earlier, then there are some extra resources linked into today's lesson that you can find on my website. So you've got the address there, and if you go to the bit that says Internet School on the top right and then drop down to the resources for this week, you'll be able to pull out any of those extra bits to work through in your own time after this lesson. So in there, what we've actually got are some bits to do with our investigation that we can do on our online simulation, and just a couple of other questions that you can have a go at doing. So hopefully this has been useful to you, and I look forward to seeing you in our next session on Wednesday.